Hello. In today's lecture, we are going to look at how to design an ultra wideband antenna. By the way, I'm Dr. A. Sriram, working as an assistant professor in the Department of ECE, SRM Institute of Science and Technology, Katangaluttu, Tamil Nadu, India. And before we get into this designing of an UWB antenna, I mean ultra wideband antenna, let us see what is meant by ultra wideband. So ultra wideband, it is nothing but it is a frequency range which is lying between 3.1 gigahertz to 10.6 gigahertz that is being defined by this Federal Communications Commission, and this frequency is being widely used for different types of application because that has that very important characteristics that which can have it transmit the data at very high data rates over the short distances with a minimal power consumptions. So there are several frequency band that has been used. You look at this ultra wideband, which is ranging from 3.1 to 10.6 gigahertz, in which you have several frequency band and several applications that may lie on. So we can make use of this ultra wideband antenna for the different kind of application to have a data transfer. What are the significance of ultra wideband technology? Because it has a very high data rates to handle different types of communication with high capacity, and which has a very low power consumption. As I said, when you want to integrate such an antenna with a battery power source, the battery cannot be drained very fast. So ultra wideband antenna is had that very specific character, the low power consumption and then low power spectral density, and which also mainly used for this MIMO communication, which has a very high multipath immunity and fine range resolution capabilities, which is being used for different types of application. There are a few important applications that I have listed in this slide. One is that Internet of Things, and next one is automotive communication, which can be used for this healthcare, and which also mainly used for this defense and many more like wearable application. Also, we may go for using this ultra wideband antenna. So looking at these applications of this ultra wideband antenna, one of the important applications is that short range communication. So which is used for this high data speed transfer communication, especially when you go for streaming that HD movies, and you want to have transfer of data between the devices at high data rates, and especially by using this wireless USB, and which also has a very low latency communication, because when you want to play a game or with any other data communication, that should have a very low latency, especially for this VR or AR communication system. You have that peripheral devices which being fixed in your body. When you move the devices accordingly, the same thing has to be reflected on the screen also. So we need to have very faster data transmission with a very low latency communications. And next one of the application is that precise location positioning. And we may look at it this indoor navigation, where this UWB is being extensively used in that indoor environments where the GPS signals are unreliable, such as we may look at the warehouses, airports, and malls. The next one is the asset tracking, which can track that. You may look at in the industry sites. People may want to count the number of equipments or the tools are inventory like, and we may also look at these healthcare centers. And next one is the real-time location systems for monitoring the employees and the patient in facilities like hospital and means. And especially we may look at some nuclear plants where the employees may work inside the nuclear plants, need to have the health monitoring, where we can have this ultra wideband antenna frequency ranges. We may go for using it. And next, very important one of the application is that automotive communications, where we may look at the several features are there, where few I have listed on this slide. You may look at that keyless entry systems, where the UWB enables secure and precise communication between the car and its a key fob. And next one is a parking assistance, and it assists a proximity that the decision and the collision avoidance. And vehicle to everything, you like to have the ultra wideband can contribute the communication between the vehicles and the pedestrians, and as well as in that can also be used for that advanced driver assistance systems. And next one is the military and defense, where the radar system, where the UWB is used for penetrating through walls, and the ground for surveillance and that detection. And communication system, you like to have the secure and high-speed communication in the tactical for the tactical operations, and search and rescue, where the landslides are there, where you need to locate that location accurately in the disaster recovery efforts. And next one is the consumer electronics. As I said, you may look at this augmented reality, AR, VR, virtual reality. This UWB enables the precise positioning and enhancing immersive experiences as it have very high data rate speed and wide bandwidth. And besides, it also has this low latency. And especially for these wearables, also can be used for this UWB application for fitness tracking and health monitoring with a low power consumption. Because as when you go for this wearable communication, when you go for an antenna fixing on your body, not in body, it is on body, then the power should not affect that cells of our human tissues. So we should have a low power consumption, this ultra wideband antenna, which has that one of the very future that low power consumption. Next one is the smart home and the IoT devices, and which can be used for interconnecting the multiple devices at different locations inside our house, which can have a coordination between them. And next one is the gesture recognition, because the UWB sensors can detect the movement and the gesture, which enables a touchless control of the smart devices. And next one is the secure access. When you look at the security of it, the UWB provides enhanced security for smart locks and the access the control systems. So we have seen a lot of applications where this UWB technology that can be used for. So one of the major advantages of this UWB technology is the low power consumption. Next one is that we can have that precision, because the UWB offers the location accuracy within a very few centimeters. And next one is the minimal interferences, because that operates across a wide spectrum, and that can have the reduction in the signal congestion. Moreover, that we have seen all the things and the side of the theory of ultra wideband frequencies and technology where it's being used. Now we look into the next part of this video is that designing an ultra wideband antenna. So there are some important matrices that need to be considered for designing an UWB antenna. One is first one is that what are the requirements for designing an UWB antennas. Next one is what are the design challenges we are going to face while we design an antenna. Next one is what is the design parameters we have to give more important to it. Now, looking at the requirements for designing a UWB antenna, we need to have an antenna that should provide a large impedance bandwidth that is covering from 3.1 to 10.6 gigahertz, and that also should have a high radiation efficiency, because that need to minimize the energy losses. Then compact size for the integration into small devices. When you go for wearable devices or integrating on that automotive communication, the antenna should be very compact in size so that that can be fixed anywhere else. And now next one is the stable and reduction radiation patterns that should have a reliable communications based on the application, because some application requires the directional radiation pattern, some application requires omnidirectional, some application requires the bidirectional. So based on the application wise, we should have a stable radiation pattern which can ensure the reliable communication. And it also should have the requirement of low group delay, because that it is need to minimize the signal destruction. Now, what are the design challenges we are going to face? The first one is that we are going to design an antenna that need to cover a very large impedance bandwidth, that is 3.1 to 10.6 gigahertz. So our antenna should provide a good impedance matching over the large impedance bandwidth. Next one is the compact size and the performance. So balancing the minimization of this size of an antenna and the whose performance should not go down. So that is also very important. So the efficiency should be high by balancing the minimization. Next one is the interference management, because as you know, the frequencies which is covering from 3.1 to 10.6 gigahertz, which can come with the multiple bands within that. So we need to have the avoidance overlapping with the existing narrowband systems, and radiation efficiency, which also should overcome the losses due to the compact designs. Now, what are the design parameters that we need to look at to validate our design of UWB antenna? First one is a return loss, but because that reflects the impedance matching between that frequency ranges of 3.1 to 10.6 gigahertz. And next one is that voltage standing wave ratio, that is VSWR, that should lie between less than 2. And the bandwidth need to be measured. That must be less than minus 10 dB, and the gain and efficiency are the very important matrices for that performance. Then radiation pattern, the what for what type of application, what kind of radiation pattern we require, where we require this omnidirection pattern or the directional pattern, which can be differing based on the application side. So still now we have looked at what are the application, where is being used, what are the requirements, what are the what are such, characteristics of UWB antennas. All those things we have seen. Now let us see how to design ultra wideband antenna using a CST tool. So for this, I have my scholars. They will explain how to design a UWB antenna. For that, they have referred one base paper. From that, they will replica the same design what is available in the paper to our CST tool. So it may help you for learning how to design an antenna using CST tool for these ultra wideband applications.